Number 1, draw a parabola with the given focus and directrix. So in this lesson, we define parabolas as the set of points that are equidistant from a focus, which is a point, and a directrix, which is a line. So we defined a parabola as the set of points that are equidistant. That's the key thing for parabolas. They're equidistant, which means there's an equal distance between the parabola and the line and the parabola and the point. So if I have this directrix here, that's my directrix, and there's my focus. Equidistant between them, I know there's that point right there, because those two red distances are congruent. And that point, that represents the vertex. And then from there, the parabola never touches the directrix. I want to be equidistant from it. So the parabola is opening this way, such that, this is just a sketch, if I pick any point, the distance from the focus to the parabola and the parabola perpendicularly to the directrix is congruent. Whatever points I pick, here's another point over here. Focus to parabola, parabola to directrix. Those two distances are congruent. It's equidistant from the focus and the directrix. Derive an equation for a parabola whose focus is 0, 4 and directrix is the x-axis. So the first thing we have to do is sketch. You always have to sketch a picture. So I have a focus of 0, 4. So 0, 3, 4. There's my focus of 0, 4. Maybe we label it with an F. And whose directrix is the x-axis. So the first point that we always find is the vertex. The vertex is equal, it's the midpoint between the focus and the directrix. So if I'm here at 0, 4, and this is y equals 0, the x-axis, in between that is going to be the point 0, 2. That's the midpoint, which is the vertex. This parabola is clearly concave up. And there's two ways you can do it. You can memorize the formula, which I strongly recommend you do, or you can say, well, I'm equidistant from the parabola, I'm going to call that the point x comma y, and the directrix. Those two distances, whether my drawing says it or not, are congruent. So I need to find the distance between these 2 points and the distance between the parabola and the directrix. This is the point, has the same x value. I know the y value is 0. So if I set up 2 distance formulas, let's do focus. Let me change colors here. We'll do this pinkish color here. So focus to the parabola, that's the square root of x minus 0 squared plus my change in y squared. X minus 0 means I need to do y minus 4 squared equals this blue distance here. Well, the distance there is the square root of x minus x squared plus y minus 0 squared. Okay, well, if 2 square roots are equal, I don't need the square roots. I could square both sides, and I end up with x squared, because that's what x minus 0 is, plus, well, how do I do y minus 4 squared? You make a table and get y squared minus 8y plus 16 equals, well, x minus x is 0, so we say goodbye to that term. Y minus 0 squared is y squared. And we solve for y. So this is distance formula. This was squaring and expanding. So that was like a squaring step. And now I solve for y. It's always going to happen that you have a y squared on both sides, so those get eliminated. And I'm left with x squared minus 8y plus 16 equals 0. How do I get y by itself? I'm going to add 8y and get x squared plus 16 equals 8y. Divide by 8, divide everybody by 8, and get 1 over 8, x squared, plus 2 equals y. That's the equation of this parabola. The shortcut way of doing it is using vertex form and saying that y equals 1 over 4p times x minus h squared plus k, where h and k are the vertex, and p is the focal length. P is the focal length. That's saying how far apart is the focus and the vertex. So in this case, p equals 2. So I take that number, multiply it by 4, and flip it. So using this formula, I get 1 over multiply it by 4, 1 over 8, times, well, the vertex we said was 0, 2. X minus 0 squared plus 2, which is exactly what we got by deriving it using the distance formula. So, if you like using this little formula here of saying, okay, I've got vertex form, I want it to pass through the point 0, comma 2. You make that the vertex, and all you have to do is determine the leading coefficient. It's 1 over 4p. My focal length here, focus to vertex, is a distance of 2, so it's a leading coefficient of 1/8. Number 3, the directrix of the parabola has the equation y equals 1. Find the coordinates of the focus. So I have no idea what this parabola looks like because it's not in vertex form. So let's get it into vertex form. I'm going to add 24 over, and then divide by 8. So y equals 1/8 x plus 2 squared plus 3. So if I sketch a picture of this, I know I have a directrix of y equals 1. And what's the focus of this what's the vertex of this parabola? This is in vertex form. So I know the vertex is shift left 2, up 3. So left 2, 1, 2, 3. So it's this point here at negative 2, 3. That's the vertex. And the parabola opens upward because I have a positive leading coefficient. The vertex is always trapped inside the parabola. It's inside the parabola, but how far? Well, the vertex to the directrix is 2 apart because that's 3 to 1. So the vertex to the focus has to be 2 apart. So I need to go up 2 units from where I was. Up 2 units would give me negative 2, comma 5. Another way you could have looked at this is said, wait a minute, I've got an 8 in the bottom there, so my focal length has to be 2, because that's 4 times my focal length. So that's another way you could have known the focal length from the vertex to the focus is up 2. But being able to sketch that picture is the most essential thing after this lesson. Label the focus and directrix and derive the equation of the parabola. So I've got a focus here at 1, comma 3, and y equals 1 is my directrix. So we see the parabola here has a focus, a focal length of 1. So that's our p-value. And our vertex is the point 1, comma 2. So we can cheat. We can quickly get the equation of the parabola by saying y equals, multiply that number by 4. 1 times 4 is 4, so 1/4 x minus 1 squared, shift right 1, and up 2. That's the equation of the parabola. Or if you actually wanted to do all the work out, you would say, okay, coach, I'm picking a point on the parabola called x comma y. That distance needs to be congruent to that distance. Those two distances are equal. So the distance between the parabola and the focus, that's the square root of x minus 1 squared plus y minus 3 squared equals the distance from this point down to the directrix. Well, what do I know about this point? Its y value is 1. I have no idea about the x value. It's the same x value there. So I get x minus x squared plus y minus 1 squared. I don't need the square roots because I can square both sides. When you work with these parabolas, don't touch the x minus 1. Never square the x's when we're dealing with these up and down parabolas, because otherwise it wouldn't be in vertex form. So leave your x's alone. We'll square the y out. Y squared minus 6y plus 9 equals, well, x minus x squared is 0. Y minus 1 squared, square the first, 2 times their product, square the last. The y squareds will always divide out. And I'm left with x minus 1 squared minus 6y plus 9 equals negative 2y plus 1. I want to get y by itself, so let's move that y over. Minus 1 minus 1. And I get x minus 1 squared plus 8 equals 4y. Dividing by 4 gives us the result I want, because that gives me 1/4 x minus 1 squared plus 2 equals y. This is in vertex form. If they wanted it in standard form, you would have to square that out, then distribute in and combine like terms. So if you wanted it as a trinomial, ax squared plus bx plus c equals y, then you'd have to square that out and go from there. But I normally leave my answers in vertex form because it's nice and easy that way. So you've got two options. Know the little rule. 1 over 4p x minus h squared plus k, y equals that. Or you can do this lovely algebra of the distance formula. Your choice. Find the equation of the set of points equidistant from 4, 3 and y equals 5. Draw a picture. I've got 4, 1, 2, 3, and y equals 5. So that's my focus, and this is my directrix. So the vertex is the point, it's the midpoint between the focus and the point that's perpendicular to the directrix, so it happens to be here. If that's a y value of 5, my vertex, doesn't hurt to write it, is 4, 4. So you can quickly cheat and say my focal length here is 1. This parabola, though, can't be concave up. It needs to be a concave down parabola. Otherwise, I cross through the directrix. It's like an electric fence. You can't touch it. You got to open away from it. So I know my equation is y equals. My focal length is 1, so I'm going to multiply that by 4. 1/4 x minus 4 squared plus 4 x minus h squared plus x minus h squared plus k. But here's the thing, I need my parabola to be concave down, so I need a negative leading coefficient there. I need a negative 1/4. To show you how to do it with the distance formula, you pick your favorite point and call it x comma y. Focus to parabola is the same as parabola to directrix. The focus is 4, 3. So let's set up that distance. Focus to parabola, that's the square root of x minus 4 squared plus y minus 3 squared equals this distance. Well, what point is that? I know the y value is 5. I have no idea what the x value is, though. The square root of x minus x squared plus y minus 5 squared. Don't touch the x minus 4 squared because I'm trying to get y by itself. I don't care about the x's. We should be pretty comfortable at squaring things now. Square the first, 2 times their product, square the last, equals, that's 0. Square the first, 2 times the product, square the last. I'm trying to get y by itself. My y squareds we can say goodbye to. Goodbye, goodbye! And we end up with, okay, I got to get y by itself. So let me add the y's over. Subtract 25. And I get x minus 4 squared minus 16 equals negative 4y. When I divide by negative 4, we get the answer I got by using our little cheat. I got a negative 1/4 x minus 4 squared plus 4 equals y. That's exactly what we got by using that nice little cheat there. So tomorrow we continue practicing with these focus directrix definitions of the parabola. Remember, the parabola is the set of points that are equidistant from the focus and the directrix.